Thank you. Thank you for the introduction. Hi everyone. I am Teruhiro Yamaguchi. I am a graduate student at University of Okui, Japan. Today, I'd like to talk to you about engineering framework to utilize miniaturized charpy type SEB specimens to predict GSE of full-sized specimens. Here is the content of my presentation. Predicting test specimen size effect on fracture toughness in the ductile to brittle transition temperature region, denoted as GSE, is important in structural integrity assessment. Considering the large scale and the test specimen size dependence on GSE, an efficient method to predict GSE of full-sized specimen from that of the miniaturized specimen has been of interest to engineers and researchers. Because ASTM in 1921 requires the value of M should be larger than 30, it has been considered that 5 square millimeter specimen is the smallest specimen that can be used efficiently if the requirement of M is satisfied. We first sought to re-examine Chen's opinion that it is necessary to distinguish the concept of the minimum toughness or the lower boundary of toughness values from that of the scalar band of toughness. The former is a definite parameter determined by the specimen geometry and yielding properties, and the latter is a statistical behavior determined by the distribution of the weakest constituent. We interpreted Chen's opinion as meaning that at least lower bound JC for a specific specimen can be predicted by running an elastic plastic finite element analysis EP-FEA with a given stress-strain relationship and a failure criterion. For the failure criterion, we considered one of the modified Ritchie-Not-Rice failure criterion, that is, 4 delta T sigma 2 to C criterion, which predicts the onset of the cleavage fracture when the crack opening stress sigma 2 2 measured at the distance from the crack tip equal to 4 times CTOD, crack tip opening displacement delta T, here in alpha denoted as sigma 2 2 D, exceeds a critical value sigma 2 2 C. This criterion was validated as explaining the crack depth dependence on JC by Dodds et al. And the test specimen thickness effect on JC on the condition that the value of M is larger than 60 by us. Given these observations, we thought that even in the case that the value of M is smaller than 30, JC of whether smaller than 30, if sigma 2 to D can maintain the stress level for increasing load, and if obtained critical stress sigma 2 to C for the miniaturized specimen is identical with that of full-sized specimen, we can predict fracture toughness JC of full-sized specimen. In this work, considering the fact that it is likely that cleavage fracture might not occur for miniaturized specimen, it is validated that whether cleavage fracture will occur or not can be predicted from sigma 2 to C obtained from full-sized specimen. And when cleavage fracture occurred, the fact that JC of miniaturized specimen can be predicted from JC of full-sized specimen is confirmed to validate proposed framework. Given that the room temperature tensile to yield stress ratio for Euro RPVs and Japanese RPVs is 1.3, 0.55% carbon steel, this F55C, which is known to have a stress ratio of 1.8, was selected for the examination and tested at 20 centigrade. Shall we impact test results and true strain curve are shown in these figures. The fracture toughness tests were conducted accordance with ASTM E1921. For the full-size specimens, 25 square millimeter specimen was considered. From the fracture toughness test results, the master curve reference temperature T0 was obtained as 25 centigrade. The experimental results were compared with the master curve 2% tolerance band as shown in this figure. We see from this figure that the experimental results were sufficiently conservative compared with the master curve tolerance band. The details of EP-FEA are summarized on this page. The FEAJ, designated as JFEA, was evaluated using load versus crack mouth opening displacement diagram based on ASTM in 1921. And CTOD was measured at node A, as shown in this figure. The relationships between sigma 22D, sigma 22 measured at the distance from the crack tip equal to 4 delta D at the midplane, at the specimen midplane, and JFEA are summarized in this figure. From experimental JC and EP-FEA results, the value of sigma 22C over sigma ys equal to 3.82, but for the full-size specimen was obtained. From these experimental results and this empirical formula, the 10 square millimeter specimen was selected as the specimen that the value of n will be close to 30. As smaller specimens, 3 square millimeter specimen and 2 square millimeter specimen were selected. The EP-FEA results are summarized on this figure, on this page. For the 10 square millimeter specimen, the sigma 22D showed the converging tendency for increasing load. Therefore, it was considered that cleavage rupture will occur on the 10 square millimeter specimen. On the other hand, for the 3 square millimeter specimen and the 2 square millimeter specimen, sigma 22D was not converged, and thus they were predicted as cleavage rupture will not occur. Regarding the 10 square millimeter specimen, which was predicted as cleavage rupture will occur, JC was predicted to be 58 Newton per millimeter. So test results are summarized on this page. Whether cleavage rupture will occur or not was appropriately predicted by 4 delta T sigma 22C criterion. And the predicted JC for 10 square millimeter specimen was sufficiently conservative compared with the experimental results. And note that the values of n were smaller than 30. in this work, considering the fact that it is likely that cleavage fracture might not occur for miniaturized specimen, it was validated that whether cleavage fracture will occur or not can be predicted from sigma 2 to C obtained from full-sized specimen. And when cleavage fracture occurred, the fact that JC of miniaturized specimen was can be predicted from JC of full-sized specimen was confirmed. Therefore, the applicability of proposed framework was validated. Proposed framework was validated. And these are the conclusions of my presentation. Thank you for your close attention.